Good morning, folks. So I only have one short example to get through after going over the exit ticket, and then I'm going to let you have the rest of the time dedicated to my class today to work through either the homework problems or the worksheet as some extra practice for your upcoming quiz. Just a friendly reminder, it's only going to be problems related to this couple sections of formulas, your sum formulas, difference, double, and half angle formulas. So let's talk about the exit ticket from yesterday. We had this expression that was first reduced, recognizing that it's simply the structure of the half angle for cosine. If the angle is 44, the half angle is 22. There we have the simplified process. 22 degrees is nothing I would expect you to simplify further, so you could have left it right as this expression. If it was something like cosine 30, you would then go and reduce to rad 3 over 2, or whatever the respective value would be. For part 2, changing up the variable, we have capital A. So they gave us that cosine was 1/4 and that A was acute. Well, if angle A is acute, angle A has to be quadrant 1, so then half of A also has to be quadrant 1 as well. So that's why I'm going to take the positive root, because sine is positive in quadrant 1. And simply using this formula, we're going to plug in with the given information we have. So 1/4 was the value for cosine A. 1 minus a fourth divided by 2 gives me 3/8. Radical 3 over radical 8 reduces to this, and then a quick rationalizing gives us rad 6 over 4. So this is an exact answer, and this is how I would expect you to simplify the answer. I would not want a decimal on this. And lastly, there are multiple ways you can kind of approach this, and you're going to see with the more formulas we have, the more approaches you have to simplifying or evaluating. So I'm going to go with one that I suspect some people used. Simply recognizing that 15 is a half angle of 30, you can use both the half angle for sine and the half angle for cosine formulas, and a very nice thing happens when you multiply those together. First off, if 15 is the half angle, 30 was the original angle, right? So notice these are pairs of conjugates. So when you multiply the radicals, first off, you have a very nice denominator. The numerator gives you a 1 minus cosine squared of 30 degrees. Well, 1 minus cosine squared of an angle is sine squared of that angle. So now we have a perfect square numerator, a perfect square denominator, both which reduce. Again, we're going to keep it a positive root because we're still working in quadrant 1. Sine 30 is 1/2 divided by 2 gives me 1/4. There's a couple other ways you could have done that. I'm not saying it's wrong. As long as you got to 1/4 using some formula or logic, I'm okay with that. Simply plugging into a calculator wouldn't be reasonable. Excuse me. So we have one example. This is about as difficult as these types of questions might get. And it's an evaluation without a calculator of this expression. At first, it looks complicated and it can look very daunting. And you just have to recognize one or two small details here. So we have cosine of something divided by 2. Well, the something that we're dividing by 2 is sine inverse of this ratio. So I don't know what angle sine inverse of 12 over 13 is, but I do know it's going to be an angle all the same. So let's just call that theta. If this comes out to be whatever angle it is, then that means the original expression is now cosine theta over 2. Now it's in a more recognizable form. Now that's something we can make a substitution for. So cosine theta over 2, we have our formula, square root 1 plus cosine of your angle all over 2. So now the problem here is, how did I know to use the positive root here instead of the negative root? Well, go back to sine inverse. Sine inverse only lives in quadrants 1 and 4, and because it's positive, we know that this has to be a quadrant 1 angle. So if theta is in quadrant 1, then theta over 2 has to be quadrant 1 as well. So we're going to keep this a positive root. Now, again, how do I want cosine theta if all I know is cosine theta over 2? Well, what do we know about theta? We know it has a sine value 12 over 13. So we can set up a triangle. I chose a very nice ratio here, 5, 12, 13. And now we can plug in the cosine ratio from that triangle, and we get 1 plus 5 over 13 all over 2, all inside of my square root. So at this point, the trig is done, and it's just a matter of simplifying this. So 1 plus 5 over 13 is 18 over 13. All over 2 gives me an 18 over 26, which of course that reduces to 9 over 13. Well, 9 is a very fortunate number. I promise I did not expect that to happen. Square root of 9 is 3. Square root of 13 is nothing special, but we do need to rationalize that. And there's your final answer. That would be an exact answer. I wanted to go over this because I think this pops up, this inverse trig expression pops up a couple times on the worksheet I posted yesterday, so I just wanted to make sense of the answer key and at least give you one modeled example before you just kind of jump into my solutions on that. So again, take the time today, go through the worksheet, go through some book problems I'm going to be posting, review, and of course, as always, please reach out with questions. Several of you are already doing so, which is awesome. If you are confused, if you're concerned, I need to know about it. You need to be reaching out, so please do so. All right, folks, good luck.